Hello my dear students, welcome to IMS GATE Academy excellent practice question series of communication system subject. So in this particular session we will discuss variety of questions regarding SSB-SC. In the earlier session also we have discussed the questions related to SSB-SC. In this particular session we are going to continue, right? So those who are attending very first time regarding this particular series, okay. So earlier I have discussed various questions regarding the first chapter regarding amplitude modulation, regarding DSB-SC, and of course regarding SSB-SC also we have discussed few questions, right? So kindly watch those videos also. All these series of video lectures will help you a lot for your coming GATE exam, right? So this topic is also common for two branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So this is the first question. This is a question related to the power calculation, ratio of power of SSB-SC signal with that of AM signal. So this is the NAT question. Whatever the answer you are getting, you can round off to the 3 decimal places. here you are having the AM system. They have given the modulation index. Given modulation index equal to 0.6. Modulation index equal to 0.6. Here you have to calculate ratio of single sideband signal power. So that means SSB-SC, single sideband suppressed carrier power to the AM signal power, right? So for easy understanding, I will discuss the standard formulas for AM, and with the help of that you can easily extract regarding the power of SSB-SC signal. After that you can calculate the ratio according to whichever quantity they are asking first, and then with the second quantity. So in AM, the amount of power required is equal to PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. So here if you observe, if you multiply PC with both the terms, you are getting PC into 1 is nothing but PC. So that is nothing but carrier power, and another quantity that you are getting PC into mu square by 2, that is the total sideband power, right? So in AM signal you are having two sidebands and along with that carrier. So the first term is given the carrier power and the second term giving the total sideband power, right? So here you want single sideband. So that means whatever the total sideband power you are having, from there you have to take divide by 2 or half of that value, right? So in SSB-SC, the power required. Since you are having only in the single sideband, so I am representing as P suffix SB, right? So PC into mu square by 2 divide by 2. So that is nothing but PC into mu square by 4. PC into mu square by 4. Now in this question they are asking SSB-SC signal power in the numerator and AM signal power in the denominator, right? So I will represent single sideband SSB. P suffix SSB divided by PT. So here you are having PC into mu square by 4 divided by this expression PC into 1 plus mu square by 2. So here PC will get cancelled. You can take the LCM in the denominator. You can take 2. You will get LCM as 2. Just do the simplification here. You will get numerator. You are having mu square by 4. So for the timing I am representing like this. Here if you do the simplification, you will get LCM as 2 plus mu square. So here 2 times. Okay, so that means from here you are going to get single sideband power to the AM power. You are getting mu square by 2 plus mu square by 2 into 2 plus mu square. Mu square divided by 2 into 2 plus mu square. So here they have given mu value as 0.6. So just perform squaring on both sides. You will get mu square is nothing but 0.6 whole square, that is nothing but 0.36. Mu square is nothing but 0.36. So just substitute this value here. Mu square is 0.36 divided by 2 into 2 plus 0.36. So here 2.18 times. So 0.18 divided by 2.36. So just do the simplification and tell me what is the answer you are going to get. Yes, I hope all of you are getting this answer. 0.7627. 0.7627. So here this one you can make it approximate like this, 0.076. Here the last digit value is 7, so which is greater than or equal to 5, so you can add 1 here, right? So 2 plus 1 is 3. So that means you are getting 0.0763. So this value is less than 5, so that means whatever the earlier value you are having, you can copy as it is, 0.076. So here in the question they are asking you have to round figure your answer to the 3 decimal places. So after the decimal point you have to consider only 3 decimal places. So the final answer for this question is 0.076. 0.076. I hope it is clear for everyone. So now let us see the next question. All of you give a try. This is the MSQ. Either one option or more than one option can be correct. All of you give a try. This is the MSQ. So whatever 4 choices you are having, among these choices whichever are correct you can choose. So first of all, read the question. Here the power of the message signal is given 0.7 watt. The power of the message signal. So first of all, read line by line, and whatever the given data is there, you can note down. Okay. So with that, you can easily understand what the given data is there, what they are asking. So accordingly, you can use the respective formula and you can substitute the values and you can easily find out. Okay, right. So the power of the message signal given, that is 0.7 watt. Power of the message signal, so I am representing as P suffix m, which is given as 0.7 watts. Power of the message signal is given as 0.7 watt, and the message is band limited to a frequency of 15 kHz. So that means regarding the message signal, the maximum frequency they have given, that is nothing but 15 kHz. 15 kHz. The maximum frequency of the message signal or modulating signal, that is 15 kHz. 15 kHz. Now, if the modulation scheme used is SSB-SC, so here they have mentioned the modulation technique used is SSB-SC. Okay, modulation technique used as SSB-SC, and the power of the carrier is 100 watt. The power of the carrier is 100 watt. So P suffix C is 100 watt. Carrier power is 100 watt. Now the question is, here you are having 4 choices. So among these choices, whichever are correct, you have to choose. Then choose the correct option or options. This question is MSQ. Either one option or more than one option can be correct. Now if you look at all the choices, once if you read the choices, 2 choices you are having related to the power of the modulated signal. Power of the modulated signal. So that means power of SSB-SC signal, right? So in one choice it is mentioned like 70 watt, in another choice it is mentioned like 35 watt, right? So, and then other 2 choices are regarding bandwidth of SSB-SC signal only, bandwidth of the modulated signal. In one choice it is mentioned 30 kHz, in another choice it is mentioned 15 kHz. Now at least after reading the question and when you look at the choices, without solving the question, at least you can guess, right? So out of 4 choices, from option A and option B, at most one can be correct. I am saying at most, that means among these 2, at max one can be correct. Okay, that means there is a possibility even both the choice also cannot be correct, like that, right? Right. Similarly here, among option C and option D, at most one can be correct. At most one can be correct, right? So among A and B, at most one can be correct. Among C and D, at most one can be correct, because option A, option B related to the power, whereas option C, option D related to the bandwidth. Okay. So once if you are calculating the power of SSB-SC signal, with the help of that you can choose among these 2 whichever is the correct one. Okay. Similarly, when you calculate bandwidth, among these 2 whichever is the correct one, you can choose. Okay, right. So here first of all, 2 choices you are having related to power. So let us calculate regarding the power of SSB-SC signal. Power of SSB-SC signal. So just now in the previous question we have mentioned regarding power of SSB-SC signal, which is nothing but PC mu square by 4. PC mu square by 4, right? This formula now you can use. Power of SSB-SC signal. So for the time being I am labeling as P suffix T. P suffix T. Otherwise if you want you can assume like P suffix SSB. No problem. Power of SSB-SC signal is nothing but PC into mu square by 4. PC into mu square by 4, right? Now when you look at the given data, whether we are having mu, we don't have. Regarding PC, yes we are having. Regarding PC we are having, but regarding mu we don't have. Right? So how we can write mu? Any guess? Since mu is not given, what we can do? Yes, in SSB-SC signal, and DSB-SC signal, mu is nothing but what? AM. Mu is nothing but AM, right? So PC into AM square by 4, since mu equal to AM. since mu equal to m. So this is the surprise or suspense in this particular question. Okay, if you observe the previous question, in the question itself directly mu value given, but in this question mu value directly they not given, but while we are discussing the mathematical equation regarding the power calculation or SSB-SC signal representation or DSB-SC signal representation, that time we have considered mu equal to, in general in AM you got like mu equal to Ka into AM. So in DSB-SC, SSB-SC we used to consider Ka value as 1. So from there only you are going to get mu is nothing but AM. Okay, I hope it is clear. Right. Now you got AM. Okay, but here you are having power of the message signal, right? So AM also not given directly, but you can represent. Now this equation I am modifying like this. Power of SSB-SC signal is equal to, here I am writing like this, PC by 2 into AM square by 2. What I have done, it is very simple. Here in the denominator you are having 4, right? So that 4 I have written like 2 into 2. Okay. So AM square by 2 we can write as, which is nothing but what? Power of the message signal, right? So that means you are getting PC PM divided by 2. Power of the carrier signal, power of the message signal divided by 2, right? See, this is the formula for power of the SSB-SC signal, signal. See, for understanding purpose, I have written all these steps, but you can directly write this step. It is very simple. Your DSB-SC signal is nothing but what? Just the product of or multiplication of message signal and carrier signal, right? So for message signal you are having power as PM, P suffix M, and for carrier signal you are having carrier power as P suffix C. Okay, if you are having DSB-SC, since message signal and carrier signal we are doing multiplication, the respective powers you have to multiply, that's all, right? So that means PC into PM is nothing but the power, the total power of both the sidebands, right? But here we are considering only one sideband. So that means whatever the total sideband power or double sideband power you are having, you have to consider half of that. Okay, PC PM divided by 2. I hope it is clear. Now you can substitute the given values. So here PC we are having 100 watt and PM we are having 0.7 watts. Okay, divide by 2. 100 into 0.7 divided by 2. So here 50 times. So 50 into 0.7. Okay, here 0.7 you are having. 0.7 you can write as 7 by 10. So here 10, 10 will get cancelled. So 5 7s are 35. 35 watt. This is the power of SSB-SC signal. Or in the single sideband, how much if you want to transmit the signal which is having only one sideband, that time we require this much power, 35 watt. So now with this understanding we can choose option B as the correct one. Obviously option A is not correct because option A they have mentioned 70 watt, right? So that will be true for DSB-SC, not for SSB-SC. Okay, in SSB-SC we require half of the total power required when compared to the double sideband subparasitic area. I hope it is clear. Now option C, option D you are having regarding the bandwidth. Okay, so regarding bandwidth it is very simple. Bandwidth of SSB-SC signal. So as the name implies, here we are passing only one sideband. So whenever you are passing only one sideband, so that means the bandwidth you will get the FM. Okay, whatever the message signal bandwidth you are having, okay, message signal bandwidth FM you are having, right? So the same bandwidth you are going to get, because here you are considering from carrier frequency to upper sideband frequency or from lower sideband frequency to the carrier frequency. Any one of the sideband frequency, okay, or any one of the sideband range of frequencies we are passing. So that means one sideband bandwidth you will get FM. Okay, and in the question it is mentioned FM as 15 kHz. So the same answer you will get 15 kHz. So that means here option D you can choose. Obviously option C we can eliminate. C, actually for the same question instead of SSB-SC, if they mention like DSB-SC, okay, in that case you can choose option A and option C. Option A, option C will be correct if the modulation technique used as DSB-SC, okay. So here observation point is, when compared to DSB-SC and SSB-SC, the power required is getting half and bandwidth also getting half, okay. So if you want, you can make a note. Option A and option C will be correct. Options A and C will be correct. If the modulation scheme used is DSB-SC, right. So in the GATE exam, regarding MSQ questions, okay, whenever the concept is theoretical, there they can frame the options with respect to theoretical statements. But whenever you are having problematic questions, okay, that time whatever, like suppose in this particular chapter you are having the calculations regarding the power, regarding the bandwidth, right. So they can give two choices related to power, two choices related to bandwidth like this, or they can give like two choices related to one technique and two choices related to another technique. So in that way, okay, so you can expect the questions regarding MSQ whenever you are having problematic questions there, whenever you are having more than one formula or more than one calculation regarding various parameters and all. So such kind of questions you can expect as the MSQ, okay. I hope all of you are getting the clarity, right. So for this question, actual answer is option B and option D, but if they have mentioned instead of SSB-SC they have mentioned DSB-SC, then option A, option C you can choose. Yeah, next question, all of you give a try. This is also MSQ question. Yeah, choose the correct option or options. So this is also MSQ question. Yeah, it is already mentioned here, it is MSQ. So this is the model I have already mentioned earlier regarding MSQ. Say for example, when you're while solving a particular question, suppose if you are having like 4 quantities, right? So they can give all the 4 quantities, like in one choice they can give 1 quantity, right? So this is the possibility. So earlier question, if you observe, 2 choices are related to the same quantity, same parameter we can say, and 2 choices related to other parameter. But here if you observe, option A you are having AC, option B you are having AM, option C you are having PC, option D you are having PM. So that means carrier amplitude, message signal amplitude, carrier power and message signal power, right? All the 4 quantities they have given here. And this question is also MSQ. So whenever the question is MCQ, the moment you got correct option, okay, you don't need to verify remaining options whether they are really correct or not, because the moment you got one of the choices correct, directly you can choose, because for MCQ obviously one option will be correct, okay. But sometime if wherever you are facing, while you suppose for some questions if you are unable to figure out which one is really correct, okay, that time what you can do, at least try to eliminate the wrong choices. From there, whichever option is left over, that option you can choose, okay. But for MSQ, you have to verify each and every option whether it is really correct or not, okay. So that is the reason it's actually for MSQ, it seems to be that you are solving one question, but while solving that particular question, since you are having like 4 choices, okay, so if you are having 4, each and every choice is having related one different quantity or parameter, then actually you are not solving single question, you are actually solving like 4 questions, okay. That is the reason. Earlier question, if you observe, 2 choices you are having related to power, 2 choices you are having related to the bandwidth of same quantity or parameter. So that means the earlier question, okay, it's like you are solving 2 questions like that, okay. So I hope all of you are getting the the impact, or while you are solving the MSQ, so you have to after reading the question and after looking at choices, then you can decide how much time is required for solving that question. If you feel that for solving such kind of question in the GATE exam, if it is taking more time, you can pause that question at that point of time, later you can solve, okay. But for MCQ, as I mentioned earlier, it's like you are solving actually one question, but for MSQ you are solving like either 2 questions or 3 questions or more than, that means at max 4 questions like that, okay, right. So in this particular question, you are having SSB-SC signal frequency spectrum. So here they have shown for positive frequency axis, okay. For positive frequency axis means f greater than 0, that time you are having Fc plus Fm. This is a single tone modulation SSB-SC signal, that means you are having only one frequency, right. So if it is a multi-tone, you will be having more than one frequency, but here it is a single tone modulation signal. So that is the reason you are having only one frequency, that is a Fc plus Fm. So Fc plus Fm, as a name, just by observing this one you can guess, is it upper sideband or lower sideband? All of you please respond. Fc plus Fm, if you are having, is it upper sideband or lower sideband? Yes, obviously it is upper sideband. See, if you are you will be having reference frequency or center frequency, that is a carrier frequency, right. When compared to that, Fc plus Fm is what? Towards right hand side, and other frequency you will get Fc minus Fm, that is left to the Fc, right. So when you observe Fc minus Fm and Fc plus Fm, obviously Fc plus Fm is what? Greater. So that is the upper sideband, and Fc minus Fm if you are having, that is the lower sideband. So for the time being, in this particular spectrum they have given upper sideband frequency component, okay. So either they, in some question they can give upper sideband, sometimes they can give lower sideband. So any one sideband frequency component if you are having, that is nothing but single sideband. And here in this particular frequency spectrum, at carrier frequency you will be having somewhere here, there the signal strength is 0. That is the reason here SSB-SC, single sideband suppressed carrier, right. So here at Fc plus Fm, they have given the signal strength or amplitude, that is 1.5625, okay. Now, okay, you can read this question, this part of the question after some time, okay, just by observing this particular frequency spectrum, okay. First of all, write the signal strength at this particular frequency, See, when you are having AC cos 2 pi f ct, when you are having AC cos 2 pi f ct, that is a time domain signal. If you apply Fourier transform, you will get two impulses. Okay, one impulse you will get on the positive frequency axis, one impulse you will get on the negative frequency axis. Okay, so initially you are having AC cos 2 pi f ct. For that particular signal, AC is the amplitude. Okay, when you are representing on the frequency spectrum, there that time the signal strength will become half, AC by 2, AC by 2. Yes, Shiva, in the previous question, while we are solving, while in order to get the standard equations, we will consider, that is the assumption, Ka equal to 1. Like what are the standard formulas we got regarding the power calculation and regarding the bandwidth calculation, everything regarding the standard formula, like example, like m of t into c of t, right? So if you want, I will explain here also. Just one second. Yeah. Say for example, I am considering AM. S of t equal to AC into 1 plus Ka into m of t into cos 2 pi f ct. Shiva, do you know this equation regarding AM, standard equation? AC into 1 plus K into m of t into cos 2 pi f ct. Okay, I hope you know, right? This is standard equation of AM signal, right? Yes, very good. Now, here if you observe, you are having, okay, if you want, you can split. Okay, what you are going to get? AC into 1 into cos 2 pi f ct. That is AC cos 2 pi f ct. Okay, another term what you are going to get? AC into Km of t into cos 2 pi f ct. Right. So when you are splitting, you are getting two terms. One is related to the carrier component, another one is related to the both the sidebands, right? So from AM, if you want to get DSB-SC, we are suppressing carrier component. So that means AC cos 2 pi f ct we are making 0. Okay. So from there, what is the equation you are going to get? You will get AC Ka m of t into cos 2 pi f ct. Okay, right. Now here AC into cos 2 pi f ct is nothing but your carrier signal. Okay, if you want, you can represent like C of t. C of t is nothing but AC cos 2 pi f ct, and m of t is your message signal, and here you are having K. Okay, if you are choosing other than Ka value other than 1, okay, you will get the equation like this. Okay, but just in order to represent the equation in the simplified form, okay, in the simplest form, we are considering Ka value 1. If you are considering Ka value 1, that time we are going to get simply we are multiplying the carrier signal and message signal. So if you want, you can choose other than Ka value other than 1 also you can choose if you want. But just to make the representation easy, we have considered only the product of message and carrier signal. That is nothing but what? Your double sideband, you are having only both the sidebands, but there is no carrier component. AC cos 2 pi f ct is not there. From here, if you further expand, from there you will get like two sideband, like C of t you are considering like AC cos 2 pi f ct, and m of t you will consider like AM cos 2 pi f mt, and just do the simplification. From there you will get upper sideband, lower sideband, and there you can consider any one sideband. That is nothing but SSB-SC. Okay. So if you want, you can choose Ka, okay, any value, but just to make the standard format or simplest format, we are assuming Ka value 1. Okay. So in the AM signal, you will get modulation index as formula like this, K into AM. Here also the same formula will applicable, but K value 1 when you substitute, from here you are going to get mu equal to A. Okay, I hope it is clear, right? Yes. Yeah. So here let us come back to this question. Okay. So here you are having at this particular frequency you are having the signal strength. Okay. So for easy understanding I am representing, say for example if you are having AC cos 2 pi f ct, if you are having AC cos 2 pi f ct, if you apply Fourier transform, okay, you will get the function like this, AC by 2. What is the signal strength you are having? Just consider half of that. You will get two impulses. Okay, one impulse you will get at Fc and another impulse you will get at minus Fc. So that means delta of F minus Fc plus delta of F plus Fc. Okay, so when F equal to Fc, that time we are getting one impulse which is having the signal strength AC by 2. Similarly, at F equal to minus Fc, we are getting the signal strength as AC by 2. So that means it is very simple. Whatever like cos signal, similarly sin signal, there you will get like 2j term, but when you consider magnitude wise both will be like same. Okay, for cos you are getting plus here, whereas for sin you will get minus here. Okay, right. So AC cos 2 pi f ct, for this if you are applying Fourier transform, you are going to get two impulses. One impulse exists on the positive frequency axis, another impulse exists on the negative frequency axis. At both the frequencies you will be having the same signal strength, that is nothing but AC by 2, AC by 2. Okay. Similarly, so from here if you observe that K into AM when you have considered like mu. Okay. So now if you observe the second part of the equation, like AC and M of t if you consider like AM into cos 2 pi f m t, from there you are going to get K into AM as mu. So AC into mu cos 2 pi f m into cos 2 pi f ct, right? So from there when you are simplifying, okay, for the timing I will write here like the other term. So initially we are having like this, AC K into M of t cos 2 pi f ct. Okay. So from here what we got, this one, right, C of t into M of t. Okay. Yeah. So regarding DSB-SC, when you consider, you are having the equation like C of t into M of t. Okay, otherwise I will write this equation, one second. So in the AM only I have considered first part of the equation, that is AC cos 2 pi f ct, another part is AC K M of t into cos 2 pi f ct. AC K M of t cos 2 pi f ct. Cos 2 pi f ct, right. So here M of t you can assume AM into cos 2 pi f m into t. AM into cos 2 pi f m into t. Here cos 2 pi f ct as it is. Cos 2 pi f ct as it is. Now K into AM we are assuming like modulation index. So that is nothing but mu. Then cos 2 pi f m into t into cos 2 pi f ct. Okay. Now you are getting in the standard format cos A cos B, but you know the standard trigonometric equation like 2 cos A cos B, right? So for that reason I am multiplying and dividing with 2. 2 cos A cos B is nothing but what? Cos sum plus cos difference, right? So whenever you are having message signal frequency and carrier signal frequency, obviously carrier frequency is large when compared to message signal frequency, right? So for the timing I am considering this is A and this is B. 2 cos A cos B, 2 cos A cos B. So from there what you will get, 2 cos A cos B is nothing but cos sum. You can add both the terms. 2 pi you can take common, then Fc plus Fm into T. 2 cos A cos B. 2 cos A cos B is nothing but cos sum plus cos difference. Cos difference. So you can subtract smaller frequency from larger. So Fc minus Fm into T. Okay, suppose if you are considering this is A, this is B, no problem. So what you will get here expression Fm minus Fc you will get. Okay, from there if you are taking minus as common, you will get Fc minus Fm only, but overall term you are going to get minus. Cos of minus theta is nothing but cos theta. It is even function, right? So there is no issue at all whenever you are considering both are cos. Okay, but just to make the representation easy, because we are considering Fc, in general the carrier frequency is large when compared to the message signal frequency. That is the reason here I have considered like this term is A, this term is B, right? So I hope all of you know this formula. 2 cos A cos B is nothing but cos sum plus cos difference. Cos sum plus cos difference. Okay, 2 cos A cos B is nothing but cos sum plus cos difference. Okay, right. Now if you observe, just you can compare. Here you are having AC cos 2 pi FCT. Here the peak amplitude you are having AC. When you apply Fourier transform, it is getting half. Okay, and here at this particular frequency on the positive x-axis or on the positive frequency, at this particular frequency you are getting one impulse, and similarly on the negative frequency you are going to get one impulse, right? The same logic here also you can observe. You are getting what you are getting here. Okay, if you are multiplying AC mu by 2 with both the terms, okay, so this is the first part, AC mu by 2 into cos 2 pi Fc plus FMT, and AC plus AC mu by 2 cos 2 pi into Fc minus FMT, right? So here Fc plus Fm is nothing but what? Upper sideband, and Fc minus Fm is nothing but lower sideband. Okay, I hope you are getting the clarity, right? I have considered the standard equation of AM in that this is the first part of the equation and this is the second part. Okay, from the first part I explained. Okay, regarding the second part, when you do the simplification, you are getting both the sidebands. Okay, but now the question is regarding SSB. So we have to consider only upper sideband or only lower sideband. Any one sideband we can consider. So according to the given question, Fc plus Fm we are having. So that means they have considered upper sideband. Okay, now you are having the part of the equation like this. Right? So for this part of the equation, when you apply Fourier transform, okay, just you can observe. Here AC is the peak amplitude, that become half. Now here in this case this is the peak amplitude, that will become half. Okay, at what frequency? At this particular frequency. Here Fc is there, in place of Fc now Fc plus Fm. So on the positive frequency axis, at this frequency you will get one impulse, and similarly on the negative frequency axis, at this particular frequency, negative of this frequency, there you will get this peak value divided by 2, like that. Same signal strength you will get at both the impulses. You will get at both the frequencies you will get the same signal strength. Okay, so just for easy understanding I have completely derived. Okay, now once if you are having this knowledge, okay, you no need to do this entire calculation in the exam and all. Okay, so by solving good number of questions, okay, you will get the familiarity. Okay, so for carrier signal when you are representing time domain, you are having the peak amplitude AC. For that, the corresponding impulse signal strength you will get half of that. That means AC by 2. Similarly, for upper sideband or lower sideband, you will get AC mu by 2 divided by 2. That is nothing but AC mu by 4. Okay, so directly I am writing here the signal strength at Fc plus Fm. The signal strength at Fc plus Fm is equal to AC mu by 2 divided by 2. So that is nothing but AC mu by 4. AC mu by 4. So according to the given question, you are having 1.5625. 1.5625. So from here you can just do the cross multiplication. You will get AC into mu is equal to 4 into 1.5625. So here once again mu is nothing but Ka into Am. So just do the multiplication, what you will get? Shiva, how much you are getting? You will get 6.25. Yes sir. You will get 6.25. Here also we are assuming Ka value as 1. Ka value as 1. So that time we are getting AC into Am. AC into Am is nothing but 6.25. So this one you can assume equation number 1. You can assume equation number 1. Yes, very good Shiva. AC into Am you are getting 6.25. Now let us read the question further. From the given spectrum we got one quantity or relation, that is AC into Am is equal to 6.25. Now let us read the question. Sum of the amplitudes of modulating signal, that means message signal amplitude and the carrier signal amplitude, when you are adding both, that time they have given the resultant value as 13 volts. Okay, 13 volts they have given. So here I am writing given AC plus Am, AC plus Am equal to 13 volts. Okay, they have given this value AC plus Am, they have given 13 volts. And let us read further in the question part. If carrier amplitude is greater than the message signal, okay, that time here whatever the 4 choices you are having, among these 4 choices whichever are really correct you have to choose. Okay, right. So here you are having AC plus Am, here you are having AC Am, right. So now we have to calculate AC Am, because in option A, option B, if you observe, in option you are having AC value, in option B you are having Am value, right. So I hope you have studied regarding this particular formula in your mathematics. Like here you are having addition of 2 variables and here you are having product, right. So you might have studied this formula, like for the timing I am considering like difference of these two, perform square. It's like A minus B whole square, A minus B whole square. So when you are having like these relations, okay, we can represent in this format like A plus B whole square minus 4 times ACAM. You can easily correlate. Here A minus B whole square is nothing but A square plus B square minus 2AB, right. So whether you are going to get same expression or not, let us see. A square plus B square, yes, it is matching. After that you are going to get plus 2 times AB minus 4 times AB. So 2 plus 2 minus 4, that means you are getting minus 2. Yes, both are matching, right. So here I want to get AC minus AM by using these two. Okay, so you can represent like this. Now you can substitute this value 13 square minus 4 into ACAM we got 6.25. So substitute here. So 13 square is 169 minus 4 6 are 24. 0.25 you can write like 1 by 4. So 4 into 1 by 4 is nothing but 1. So 24 plus 1 is 25. So 169 minus 25, so we will get 144. 144 plus 5, 149 plus 20, yes, 169. So here as of now we got AC minus AM whole square. Okay, so if you apply square root on both sides, from there you will get AC minus AM equal to 12. You will get 2 roots like plus 12 and minus 12, but in the question it is already mentioned AC is greater than AM, right? So you can consider positive. AC minus AM equal to 12. Since they have mentioned AC is greater than AM. Okay, so here you got, okay, ACAM you got and AC plus AM. Okay, suppose you can assume this is the equation. Okay, you can just add equation number 2 and 3. Just add 2 and 3. So here when you are adding both, okay, here AM will get cancelled, so that means you are going to get 2 times AC. 2 times AC is equal to 13 plus 12, that is nothing but 25. 25. So from here you will get AC equal to 25 by 2, that is nothing but 12.5. Units are volts. AC is 12.5 volt. Yes, we are getting option A is correct. Option A is correct. Okay. Now, this value you can substitute in equation number 2. AC value you can substitute in equation number 2. So from here you will get AC value you are having 12.5 plus AM is equal to 13. Is equal to 13. So bring 12.5 on the right hand side, it will become negative. So AM equal to 13 minus 12.5, so that is nothing but 0.5. Yes, AM equal to 0.5 volt. Yes, that means option B is also correct. Option B is also correct. As of now we got option A, option B both are correct, right? Now let us verify regarding option C and option D whether they are correct or not. So here you are having carrier power, here you are having message signal power. So carrier power is nothing but AC square by 2, AC square by 2. So substitute this value here, 12.5 whole square divided by 2. So all of you just do the calculation and how much value you are going to get, tell me. And similarly regarding the message signal power, which is nothing but AM square by 2, AM square by 2. Here you are having 0.5, that one you can write as 1 by 2, both are same, divide by 2. Otherwise, if you want you can represent as it is, no problem. 0.5 whole square divided by 2. 0.5 whole square is nothing but 0.25 divided by 2, that is nothing but 0.125. 0.125. Yes, option D is also correct. Option D is also correct. Right, what about option C? Is it correct or not? How much value you are going to get regarding carrier power? Just do the simplification, you will get 78.125. 78.125, right? Yes, same answer. Whatever they have given in option C, both are matching. So for this question, whatever the 4 choices you are having, all the 4 choices are correct. Okay. So for MSQ, either one option or more than one option can be correct. So for this question, all the 4 choices are correct, right? So I hope all of you liked whatever the questions we have discussed in this particular session and earlier sessions. So kindly watch this series of lectures, whatever coming in our YouTube channel. So for getting instant notification, subscribe our channel and click on the bell icon so that you won't miss even single video, right? So whoever attending very first time regarding any of these sessions, so kindly watch the earlier sessions also in your free time so that you will get maximum benefit from this series of lectures, right? So earlier we have discussed like foundation course lectures. Currently we are discussing like excellent practice questions or most expected concept series, etc. So whatever the series of lectures currently it is there, it is available in our YouTube channel in the playlist. Okay, you can just check according to your branch. You just identify the subjects which are related to your branch. So kindly watch all the series of video lectures, right? And currently from this week onwards we started the recent GATE previous questions also, right? So kindly watch those series of lectures also according to your branch and whatever the subjects are relevant for your branch. Okay, and kindly share these video lectures with all of your friends so that they also will attend these sessions. Based on the possibility they can attend in live, so that they also can get maximum benefit from this series of lectures. And due to any reason if they miss the live session, they can watch the recorded lectures also, right? So I hope it is clear for everyone. So all of you kindly subscribe our channel and click on the bell icon. So we'll meet you all in the next session. Thank you everyone.